All right, so today we're going to be talking about STEM classrooms of tomorrow. And it's going to be a proposal, and it's by all of us. So in a current classroom experience specifically for STEM, it's usually a pretty big class because it's a popular major. It's going to be anywhere from 300 to 500 people, especially if you're in Murdoch, which is shown there in that picture. There's a ton of people in there. It's really always going to be a huge, long lecture slide, and you don't really learn the information by going to lectures. Most of the time when you're doing online homeworks, you have to read the book in order to accomplish that. At least that's the idea. That's how you're supposed to learn. What actually ends up happening most of the time is people go to Quizlet and they do the entire homework using Quizlet in probably like 30 minutes because they know they can get guaranteed points. But they're not really learning the material. And it's become more of a focus on getting good grades than actually learning. So you can have an A in biology, especially in my biology class where even all the exams are online. You can literally use Quizlet for all the exams. So you can have an A in there and not know a lick of what was taught in the actual class. So we're thinking of going a completely different route, abandoning the traditional classroom, and mostly because there's been prior success using AI, specifically with an intelligent tutor system, which is shown here. This is like a little guy that you can talk to and work through the problem, and he gives you kind of hints to make you fundamentally understand the information instead of just trying to look at a lecture slide and come up with it on your own. The results are, well, first of all, is used widely in math and science departments, which is good because it relates to the STEM program that we're trying to show you. And they found that there were higher average test scores when compared to a traditional classroom. Okay, so you can make an inference that you have an improved level of understanding because of the AI systems, which means you can retain more information. So the idea is to have every student use AI and VR softwares at home because it's going to be a more immersive experience. First of all, they'll have somebody there in AI to help them through the material. Not really help them, kind of help them through, but so you actually understand it and you can work through the problems, and it's personalized. You don't have to look at a PowerPoint and either you understand it or you don't. You can work through several different models and examples that work for you. And then class time can become more about an outlet for real world applications of the material learning. So you learn double the amount because you're teaching yourself at home, you're teaching yourself better, and then you can go and apply that knowledge. And all this progress is tracked and reported to the instructor to make sure you're actually getting the work done. So you can use it can be really for anything in STEM, and it actually helps a lot more compared to a PowerPoint software. Specifically for chemical engineering, you can go up there and throw a bunch of equations at people, or you can put them inside of a power plant and see how different flow rates work with different pipes. You can actually physically examine that. Or especially for organic chemistry, which is I think the highest failed class in the entire country, right? And it's hard because you have to look at 2D pictures on a test and make 3D inferences from it. Specifically stereochemistry, and it's just a bunch of rotating around these bonds right here. And anyway, it's hard to imagine based off a 2D picture. So looking at it through 3D, AI, and VR, you can understand it a lot better. And then obviously biology, you can look at anatomy and figure out how different things work, and you're not going to actually end up killing somebody. So the benefits are really, they're limited by nothing. Americans will actually be able to keep up with other countries again because kids will want to learn because they actually are learning. It's not you go into class and just trying to get an A and using different Quizlets and stuff. You're actually learning the material, not memorizing it and then throwing it back onto a page. And you're actually getting an education worth paying for. At the end of your 4 years, you can say, wow, I actually have some skills I can go out and use in the workforce. And then by using different applications in class, you have experiences worth the time you spent there. So when you go and you work at a power plant, for example, you've seen that example before. and you can work through the problem a lot easier instead of just, oh, well, I know this is an equation. I don't really know how to apply it. So in order to implement this, we came up with a 4-phase plan, the first of which interviews key stakeholders and what their needs are and how to operate the system itself so everyone is on the same page. And then we'll move into phase 2, where we define the phasing strategy to align the pilot program itself to what the university's needs and wants are, so the exact curriculum that they want to teach to make sure that we can compile the software in order for all the students and faculty to get the most out of it they can. And then phase 3 is the pilot itself, where it's a series of 5-week sections that build up to the actual pilot. So it's them building it and making sure that all the measurements are good, and then define measurements of success to make sure like these are our end goals, and if we meet them, then it'll be a successful project. And at the very end, in phase 4, we'll present our findings to the university itself, and they'll make the decision of whether to implement this further in the STEM curriculum. And this is the entire timeline on one block. And then finally, the budget. The majority of the cost for the pilot is going to be found in the technology, not the labor. The labor is relatively easy because it's one small class, and it only requires about four people to be there: the professor, the TA, and then 2 undergraduate TAs. And the estimated total cost is about $88,000 to $89,000 in order to carry it out. In all, this is a pretty small investment in order to revolutionize the educational system, and it'll promote a better level of understanding throughout all graduates in the STEM program. This will lead to a more competent workforce, which in turn will lead to more advances than we've ever seen before.